think we're on. So, safety. We've got a chance to use this guy, but we do have to be safe. Safety, essential whenever we're using a robot, no matter if it's this little guy or one of the big guys out back. Things to keep in mind. Number one thing that you want to keep safe. People. Obviously, we don't want to destroy anything else, equipment or whatever it is that you're trying to have the robot move. But number one is people. People and equipment. So we'll look at use of safety devices, all kinds of different safety devices relative to the robot. Safety enhancing devices. I think that might be dead man switch, emergency stops, things like that. And maybe some things that you maybe haven't heard of or seen before that you might encounter in a factory. Okay? We'll look at techniques for safe teaching and manual operation of the robot. Things that we should do and shouldn't do when we're teaching or when we're done teaching and we're running it for the first time to see what it's doing. Techniques for safe automatic operation. What should you do? What can you do? What are you not allowed to do when it's running in auto mode? Regular scheduled inspection of the robot. If you're going to be maintenance and you're going to be working on them, there's some more safety guidelines as far as when you're working on it. And proper maintenance of the robot. How do we keep the robot in good maintenance so that nobody gets hurt? All very important things to do with safety. We said people was the most important. We don't want anybody to get hurt. A piece of equipment gets damaged, well, we got to fix it, but that's nothing compared to you getting hurt. So people, priority-wise, number one on the list, keep people safe. Next, external devices. What kind of things would that be?
The cage.
The cage. You want to make sure that it can't reach the cage, which when we install our cages, we're going to have to worry about that. What else? External devices. Other equipment that's around it. Other robots. Conveyors. Whatever it's picking up, or whatever it's moving, or whatever it's working on. Those kind of things. Other robots. Tooling. What's tooling? The end of arm tooling, whether it's a gripper or whether it's a welder or a spray gun, whatever it is, that tooling, you want to keep it from getting damaged. And the workpiece, whatever it is, if you're painting something, if you're welding on something. So kind of in order, most important, of course, being us. We don't want anybody hurt. Using safety enhancing devices. We talked about some of them, or you mentioned some of them. Here's a list of some of the safety enhancing devices. The fence. Physically keeps you from getting in and around the robot. In the case of this guy, it's plexiglass, keeps you from getting inside here. Okay? Barriers, chains, whatever the case may be. Light curtains, what's a light curtain do?
Invisible.
This here's a light curtain. What's that do?
It sends the light across.
Shooting all these beams of light across, and if you get in that, what happens? Or what should happen? The robot should stop immediately. Okay? We probably aren't going to have any of those on our system, but a lot of them do. If you want to have access around, be able to get in without having to move fences, when not in automatic mode, it wouldn't really affect much, but in automatic mode, that would automatically shut the robot down. Pressure mats, step on it, robot dies. So sometimes that's an option. Interlocks, what's that?
Right there.
On ours, right here, magnetic interlock, right? Magnet here, interlock tied into the electronics of the robot. We open this door when it's in auto mode, it dies. Okay? That's pretty much required any place that you're going to have a robot. If it's in a cage, the door that you open to go in the cage must be interlocked. Okay? So that's something that we'll also have on ours when we get it hooked up in the back. Warning lights. Just, hey, this thing's running, kind of a light. A lot of systems will have a warning light on it. The robot may not be moving at the time, but the warning light should tell you, hey, it's in automatic mode and it could take off at any time. Okay? Floor markings, a lot of times they'll mark the floor, maybe just the actual circumference of where the robot can go. So if it's in automatic mode, probably a good idea to know where that robot could go so you can stay out of that area. Mechanical stops, what would that be?
Physical hard stops.
Yeah, an actual physical hard stop, something that it hits at and it's going to stop. Probably not your best number one thing to use for safety, but it is there if it hits that hard stop. It is going to stop, but should set up other means of allowing it to stop without having to force it to hit a hard stop. That's not real good for the robot. Emergency stop buttons, E-stops. Notice on the control panel here we have an E-stop. There's an E-stop on every teach pendant. In a work cell like we'll have out back, there will be some E-stops inside that you can hit that will stop the robot instantly. Okay. Again, you don't want to hit it for no reason, and it's an E-stop. In case of emergency, stop it. If you just want to stop the robot to go in there and do something, an E-stop's probably not the thing to use. You'll want to stop it or put it in step mode or put it hold mode or something in that case. But in the case of emergency, hit the E-stop. Or enabling devices that would enable the robot to run, or disable it to run if it's not enabled. Setting up a safe work cell. Some guidelines. When we set up our work cells in the back, these are some of the things that we have to keep in mind. Personnel should be trained. That's why we're doing this. In an approved robotics training course, never permit an untrained person to run a robot. They don't know what they're doing, they're way more likely to get hurt. Install a lockout device that uses an access code to prevent unauthorized people from being in that area. Ours will be key locked. That's one way that we can keep people out. You could have an access code if you wanted to, or there's all kinds of methods to keep people out of that area. Ours will just be physically locked. Use anti-tie-down logic to prevent operator from bypassing safety measures. What do you think that is?
Taping something down.
We've talked about this kind of stuff with just other logic, electronic-wise, but as far as robot-wise, you can see the little picture here where the guy's forced to put 2 fingers in there before the thing's going to run. Why? Why would you want to do that?
You can't have one arm in it.
Yeah, you can't run it unless your hands are out of the way. That's what they're talking about. Okay? Arrange the work cell so the operator faces the work cell and can see what's going on inside of it. That kind of makes sense. You don't want your back to the robot. You want to always be aware and alert of what it's doing. Clearly identify the work envelope of the robot. Sometimes that's done with markings on the floor, or it's caged off, whatever the case may be. Signs, special barriers, different methods of determining or telling that is a place that the robot could possibly move to. The work envelope is the area defined by the maximum motion of the robot. So it may not be a place that it normally goes, but it still could go there. So be aware that the program location that it normally goes, it could move outside of that. Include any tooling in that. When we set up our work cell, you may change the tooling, and that changes the distance. You put something on that's a foot longer, well, now you have to worry about that range of motion being a little bit bigger. Position all controllers outside of the robot work area. Our teach pendant, our control box, it shouldn't be inside the loop or inside the caged in area. When we set up ours in the back, they will be the controls will be hanging on the outside of the fence, so they should be on the outside. Never rely on software as your primary safety element. We have some software limits that we can give the robot, but don't rely on that being the only means of safety. Okay? Mount an adequate number of E-stops inside that cage, around that cage, or the work cell. You should have some E-stops. If something happens, either you or somebody around should be able to hit that E-stop and stop that robot in its tracks. Okay? Flashing lights, audible warning devices, bells or whistles or horns or sirens of some sort. Audible warning devices should exceed the ambient noise level of the room. If you're in a factory and it's really noisy, a little bitty beeper that's beeping that nobody hears don't do you any good. It needs to be loud and so everybody can hear it. Whenever possible, install safety fences to keep unauthorized person out of the work cell. Again, for obvious reasons, we don't want somebody walking in not knowing that that robot is about to take them out. Install guarding that prevents the operator from reaching into restricted areas of the work envelope. Again, they shouldn't be able to reach over a fence or through a fence and be able to reach in there and grab something or do something where the robot can hit them. Use interlocks, we already talked about that. Proximity sensing devices, light curtains, mats, different systems that knows where somebody's at. So if somebody gets in the wrong place, the robot will shut down. Periodically check safety joints, safety clutches, the operation of the robot itself. Make sure that the robot is operating the way it should be. Hitting an E-stop don't do any good if the robot don't stop when you tell it to. So things with the robot have to be kept, maintenance-wise, have to be kept up also to make sure that brakes work and things shut off when they're supposed to. So from a maintenance standpoint, it's imperative that some things are done for safety also. More guidelines. Make sure that external devices are properly filtered, grounded, shielded. EMI, what's EMI?
Electromagnetic.
Electromagnetic interference. We don't want interference from other devices that could mess up the controls of the robot. Also, electrostatic, ESD, things should be ESD. You've already heard the high frequency whine when you fire up the servos. So radio frequency interference could cause issues. So we want to make sure that things are shielded and installed properly and grounded properly so that it don't malfunction from a safety standpoint. Make provisions for lockout tagout. We talked about lockout tagout earlier in the year. What's that all about? When you're going to be maintaining it or doing some maintenance in there, you got to be able to lock it out, tag it out, so that everybody knows who's in there working on it and nobody turns it back on when it shouldn't be on. Eliminate pinch points. What would that be? A pinch point. Yeah, somewhere where you could get trapped, where you have no way out. Not a good place to be. So pinch points, areas where you could get trapped between maybe the robot and the wall, and there was really no place else to go. Don't get in those areas. Okay. Provide enough room inside the work cell so that you can teach the robot. We want enough room around it so that you can get in there and get around it to teach the thing, and so that it has enough room to move around in normal operation. Program the robot to load and unload material safely. Kind of a no-brainer, but the material that you're picking up or moving around, you have to be able to make sure that it can do it safely. If high voltage electrostatics are present, be sure to provide appropriate interlocks and warnings. So the robot itself maybe is off, but there could be other things in there that are providing hazards. Some painting systems use electrostatics to make the paint cling to it. So if that's the case, you want to make sure not only that the robot's shut off, locked out, tagged out, but other sources of power, whether it be electrical power, pneumatic power, or hydraulic power, is locked out and tagged out as well before you get inside and start working on it. Some of that stuff will be connected to the end-to-head tooling. If materials are being applied at dangerously high pressures, provide electrical lockouts for those devices. Paint guns. Some of them use a pretty high pressure, so the robot might be off again, but if you don't lock out and tag out other sources of energy, that's a potential hazard also. Staying safe while teaching or manually operating the robot. We don't have a lot of problems with this little guy because he's all caged in and we can kind of see, but when we get into some of the bigger robots and we have to do some intricate things, you're going to be right up there close and personal with that robot. You want to make sure that you're doing things right. Okay? So, things like watches, rings, necklaces, scarves, ties. You shouldn't wear them in around that robot. Should be pretty obvious why. Why?
You get copper pull you with it.
Yeah, it could pull you with it. So It's very unforgiving. If it gets a hold of you, it's just going to go about its business. It really don't care. It don't know. It will. Know if you're using intrinsically safe teach pendant. What the heck is intrinsically safe? Any idea? Safe on the inside? Well, intrinsically safe has to do with whether it's sealed electrically, whether a spark inside the teach pendant could cause something to happen outside. Where would that be important? What could explode if it gets a spark? Gas, paint. A lot of these are used in painting. You got a robot painting a car, and you're in there teaching it, and you have all these paint fumes. If the teach pendant's not intrinsically safe, a spark inside of that could cause an explosion. So in those vulnerable areas like that, you'll want to make sure that you take that into consideration. Some teach pendants are intrinsically safe, some are not. So if you get into that situation, you've got to know which one's which and which one you can use. If you don't have an intrinsically safe, you're going to want to evacuate the area as far as air and possible things that would explode before you get in there. Before teaching, visually inspect the robot work envelope, make sure there's no potential hazards. Again, the envelope is the whole area that it can work in. Okay? Area near the robot should be clear, clean, free of oil. You don't want to slip and fall, water, debris, any kind of safety issues like that, of course, should be reported. No one should enter the work envelope of the robot when it's on, except if you're teaching it. If it's in automatic mode, you should not be in that work envelope, because you don't know what it's going to do. You might know what it's supposed to do, but that don't necessarily mean that's what it's going to do. So if it's in auto mode, you shouldn't be in there at all. Okay? Again, shouldn't be in there unless you're the one teaching it, and if you're the one teaching it, you should still be the only one in there. If you don't have this teach pendant in your hand, you have no business being in that envelope. Okay? You got this in your hand, maybe there's 4 of you working in one cell. Only guy that's allowed in that cell is the guy holding this teach pendant. He's got the dead man switch. Okay? Nobody else is allowed in there. Okay? From a safety standpoint, that's pretty darn important. Because you're running it and somebody else does something stupid and you smack them with the robot. Not a good thing. Okay? Only person allowed in there is the guy that has the teach pendant. And that's only if it's in teach mode. When you have that in T1. In teach. Okay? Never bypass or otherwise deactivate safety devices or limit switches. Okay? Everything's going to have limit switches or switches that's going to kill it when you open things. They're there for a reason. It's a safety. Don't try to defeat them. Know the path that you can escape. That robot goes berserk and comes after you. You have to have a way out. So if it's a gated thing like we're going to have out back, if you're in there teaching, don't close the gate behind you. Okay? Leave that gate wide open. That way you have a way to escape if you need to. Okay? You shouldn't go in, close the gate, and then start programming the robot. Leave that thing open. That's your only way to get out. Okay? So don't block your only means of escape. Isolate the robot from all control signals that can cause it to move other than the teach pendant. What other kind of things can make it go besides the teach pendant? What do you think? What if it's got a PLC connected to it? There could be 14 other things programmed that cause that robot to take off. Might look like it's just sitting there, not doing anything. Hey, that thing's off. But it gets an input from a PLC and it takes off. Know what other kind of things can start that thing up. Okay? Because in a lot of cases, that would be the case. You have to have this input and this input and this input, and then it's going to take off. Well, it may be sitting there right now, but it gets an input that it likes and it takes off. You don't want to be in its way. Okay? It shouldn't do that unless it's an automatic. And if it's an automatic, the door should be open, the interlock should be open, so it shouldn't move anyhow. But still a good idea to make sure you know what's going to cause that thing to take off. Once you have it programmed, you're going to want to test that program. see what it's doing. We've already done that on this little one. We've tested the program and we can run it through one step at a time. And the first time when you're done programming it, that's an awesome way to start out. You should program it one step at a time so that you know what it's supposed to do. You should know what to expect every single step. Okay? Stay outside the robot work envelope. So you've programmed it, get back outside of the work cell and run it through in step mode. Step it through one step at a time. Obviously, failure to do that could get you hurt. Use low speed motion. I know it's cool to see them go full speed, but when we're first having it run, you want it to run pretty slow. If it's going to hit something, it's much easier to stop it quick enough if it's going slow rather than full speed ahead. Use a low speed. Run your test program continuously once you've went through it step by step. Then run it continuously at a slow speed before you run at full speed. Okay? Kind of makes sense. Step it through one at a time, run it continuously slow, and then you can speed things up and make sure that it's doing what it's supposed to do at production speed. Of course, you're going to want to make sure personnel are outside of that work envelope. Nobody should be inside the cage. Okay? Blue maybe was not a good thing. Staying safe during automatic operation. Where should you be in automatic operation? Outside the envelope. That's where you should be. All personnel who operate it during production should observe all of these rules. Make sure that all safety provisions are active and there. You have your e-stops, you have your interlocks. All that stuff should be working. Know the entire work cell in the work area. Know what's supposed to happen next with that robot. The work cell again includes the robot and its envelope, the whole area that it can move in. Understand the complete task that the robot is programmed to do. In some cases, you just programmed it. You should know what it's supposed to do. Okay? It's hard to tell that it's doing something wrong if you don't know what it's supposed to do. So you should know what it's supposed to do. Of course, make sure personnel are outside the work envelope. They should not be in the caged-in area at all when it's in automatic mode. Never enter or allow others to enter the work area when it's in automatic. Okay? Again, there could be other things that are starting it up. Know the location of status switches, sensors, control things that are going to start it up. And know where the emergency stop buttons are. There should be some inside, outside the cell, on the teach pendant, on the control panel itself. Several different places that you can stop it if an emergency happens. Staying safe during automatic operation. Continue. Never assume that a program is complete just because the robot is just sitting there. It's what we were just talking about. It might be waiting for the input from something else. Okay? Some of them have one robot talking to the other robot, an interface of sort. Maybe some robot is in its work envelope. It needs to move first, and as soon as it moves, the other robot's going to take off. So don't assume, hey, it's safe to go in there because it's not moving right now. Okay? If it's in automatic mode, it's not safe to go in there. You need to have it out of automatic mode. If the robot's running in a pattern, do not assume it's going to continue that pattern. Okay? It may do something a certain number of times and then go do something else. If you programmed it, you should know if it's going to do that. But in a lot of cases, you're not the one that programmed it. Or it could just go ape crazy and do something weird. Don't assume you know what it's going to do. Okay? Never try to stop the robot with you. I can take him out. No, that's not a good idea. Even a small guy like this will shove you right out of the way. So don't try to stop the robot with your body. Hit the E-stop if it's an emergency. If it's not an emergency, put it in step mode, let it finish its step so it'll end that step in a good way and not just hold it right away. Or you can put it in hold mode. Again, if it's an emergency, by all means hit the E-stop. If it's not an emergency, there are better ways to stop it at the end of the step. It should be noted that the E-stop should only be used, again, in an emergency. In the case of this, we've already run it through step mode enough that you know you can step it through without having to hit the E-stop to stop it if it's not an emergency. When inspecting a robot, if you're in there doing some preventative maintenance or something, first thing you should do, turn it off. Turn off the controller. Okay? Just keep in mind, just because you've turned the robot controller off don't mean everything in that envelope is safe. You could have other things in there, hydraulics or pneumatics, electrostatics, other things that are causing problems. Compressed air. You might want to turn compressed air off if that's involved.
You got the code here. Thanks again for the
Not a
testing.
problem. If the robot, to do your maintenance, if the robot has to be on, obviously you're going to have it on. But if there's no reason to have it on, don't turn it on. Leave it off, do whatever maintenance that you're supposed to be doing. Okay? Again, watches, rings, ties, scarves, things like that could cause hazards you shouldn't be wearing, even if you're in their maintenance, even when it's off. You never know when somebody will do something stupid and turn it back on. You shouldn't, but you never know. If power is needed to check the robot motion or electrical circuits, you should have an e-stop close to you. Have the teach pendant there. It's got an e-stop on it. Know where your closest e-stop is in case you have to push it. Be aware that when you remove a servo or a brake, if you're doing maintenance and you have to take a servo off, or you have to take a brake off, how heavy is that robot arm? This one, maybe not so much. But you get into one of them big robots, well, you take the brake off, and that arm's just going to drop. Or if you take a servo off, that robot arm could just drop. So you need to be able to block those things up and know the potential of what could happen if you release that brake. Or you take that servo and pull it out of there, what's going to happen to that arm? That's what was keeping it up in the air. It's going to drop. Okay? It may still be connected, but it's still going to slam down. If you're in the way, it's going to take you out. Okay? So, take that in consideration. Things should be blocked up to make sure that they can't physically move if you're going to remove a brake or a servo motor. Again, when maintenancing, never enter the work envelope again when the program is in automatic or when your robot is in automatic. Before entering the work envelope, inspect the work cell for potentially hazardous conditions. Again, don't want to get anybody hurt. Again, watches, rings, neckties, things like that. You shouldn't have them on. Consider all or any overlapping work element or work envelopes. Maybe you've got another robot that's coming into that. You turn this one off, but there's another robot that comes into that envelope. You got to make sure that you're aware of those kind of things when you're working around robots. The one you shut off might not get you, but the one next to it could. Okay. Be sure that the teach pendant is with you. Pressing the enable switch and turn the teach pendant on. Be prepared to release the enable switch if you need to. Stop the robot if you're running it around or testing something from a maintenance standpoint. Whenever possible, perform maintenance with the power turned off. Okay. Also keep in mind that when you flip that switch off, there is still lethal voltages inside the controller itself. Okay. They're running on 3-phase. Ours back there 480. This one is just 220 volts in the controller itself. Still, I don't think you want to get tied into that. When you flip that switch off, that just kills the output power, but there's still input power there. Be aware that just because you flip that switch didn't kill the entire circuit. On the ones back there, we have to kill the breaker at the eye line to really kill everything if you're going to work on the controller itself. You don't want the eye line voltage to be on. So keep in mind when you flip that switch on the control panel, that don't kill the voltage, the whole thing. It just turns the robot itself on. There's still voltage in the control panel. So, warning. Lethal voltages could still exist in that controller whenever it's connected to a power source. Okay? If you physically unplug it from a wall, if it's plugged in or if it's connected via a disconnect box, if you pull the disconnect, that's the only time that thing's going to be safe to work on the controller part of it. Flipping the switch off only turns power off to the robot itself. Okay? So keep that in mind. Be aware that when you remove a servo or a brake, again, that arm could drop. Okay, make sure you're blocking things up. I'm sure at some point, some of you will get into the maintenance aspect, not just the programming aspect of the robot. Okay, releasing or block all stored energy. Okay, you've got a maybe 100-pound arm hanging out there. If that thing drops, it'll definitely take you out. Pneumatic stuff, make sure the air's turned off. We're going to have grippers on ours, so there will be some pneumatics there. Isolate the robot from remote controlled signals. Again, other things could be turning it on, PLCs, or maybe just switches or things that could start it up when you didn't really expect it to start. Again, make sure there's no place in there you can get trapped. You want to leave yourself an out. Don't close yourself into a cell. Leave the doors open. When replacing or installing components, make sure that we don't get dust and dirt and craft and corrosion in there inside the robot. Okay, want to keep that clean inside. Use only the specified replacement parts. Sometimes if you, the transistor's bad, I'll put in one that's close. Well, sometimes that's not a good idea. Use the exact replacement parts, or you could have problems. Okay, to avoid fires, damaged controllers, you shouldn't use unspecified parts. Use what's actually made for it. Before restarting the robot, make sure nobody's inside the cell. Make sure that you didn't leave tools lay around or anything out of place that the robot normally does not have there, or the cell does not normally have there, that the robot can run into. Do not remove any mechanical component from the robot before understanding what's going to happen. Hey, wonder what happens if we take this servo off. Oh, the arm drops and breaks my leg. Not a good time to find that out. You should know that ahead of time. Okay? Obviously, doing so could result in personal injury, and that's what the safety portion is all about. We don't want anybody hurt because they didn't know. We talked about that last year and this year with who's the most common person or group of people that get hurt. No, not Spencer.
Oh.
Inexperienced or new people, because they just didn't know. They didn't know that it was a potential hazard. After you're hurt, it's too late to learn. Okay? External devices. Said one of the things is we want to keep external devices safe. You don't want that robot running into other things and damaging other pieces of equipment or other things that are in that work cell. Okay? So implement the following safety procedures. Back check limit switches, make sure that they're working. Implement failure routines and programs that will provide approximate robot action or appropriate robot action if an external device or other robot's in the work cell. Okay, what's going to happen if something else comes in there? That's where some of these safety devices come in handy. Use handshaking protocol to synchronize robots. What's a handshaking protocol? Any idea? So they know what each other's doing. Okay, this robot knows when it's in the other robot's work cell, so this one's not going to come over and get in its way. Okay, they have to be able to talk to each other. Program the robot to check the condition of all external devices. It needs to know IOs of other devices, whether it's its own controller or whether it's PLC connected to it. Make sure the work cell is clean, free of oil, water, debris. Use software limits. It's one of the first things we'll do when we set up the robots in the back, is set up software limits of where it's allowed to go. Don't rely on that to be your only means of safety, but it does allow you to set up maximum places that the robot is allowed to travel to. Okay? Limit switches, mechanical hard stops. Sometimes on a robot, you'll have a limit switch. When it gets to a certain spot, the limit switch itself will shut it off. Okay? So sometimes it's good to have 2 or 3 levels of safety to make sure that thing isn't going to do something crazy or go in an area where you really don't want it to go. Use a low override speed to increase the control over the robot when you're jogging it. I know it's fun to see it go full bore, but when you're jogging it and you're trying to teach it and get it to go where you want it to go, sometimes full speed's not a good thing. You don't have as much control over it. You can't react fast enough to stop it from hitting something or someone that someone might be you. So don't go full speed ahead. Visualize the movement of the robot before you press the jog key. Where do you think it's going to go? Hopefully you can get it to go that direction and not someplace it's not supposed to go. Make sure the work envelope is clean and free of oil, water, debris. Use circuit breakers to guard against overloads. Okay? We got fuses in our eye line out there to make sure that if something goes wrong, it's going to blow a fuse or blow a breaker and not explode the controller. When programming, establish interference zones to prevent collisions when two or more robots are trying to work in the same area. Okay? So you can create a zone so that one robot, if it's in it, the other one won't come over there. Make sure that the program ends with the robot at or near a home position. When we start actually programming programs, we will start it at a home position and you should end it at approximately that same point. Okay? That way you know where it's at, where it's going to start, and where it should stop. Gives you an idea that, hey, it's at the end of the program. Be aware of signals or other operations, again, that could trigger it. If there's a switch that turns it on, or if there's a PLC input or output, that if it's flagged, it'll turn the robot on and make it move. You need to be aware of those kind of things. In dispensing applications, be aware of safety guidelines with respect to dispensing materials. If you got something that's gluing, or something that's welding, or something that's spraying paint, or whatever the case may be, you should be aware of what it's doing. Some of them can be maybe high pressure, other things that you have to take into consideration. Any deviation from these methods and practices must conform ultimately with your employer. If you're working for a company, they may have even more stringent safety standards than what we've covered here. So ultimately it's up to your employer or the place that you're working to dictate, to some extent, the safety practices. Okay? So questions, ask before you do it and go, ooh, shouldn't have done that. Okay? You can't be too safe when you're working around something that could seriously kill you. Okay? It'll grab a hold of you and throw you over the fence and just keep doing its thing. It don't know any better. You're the one that's supposed to know better. Right, Spencer?
Yeah.
That's right. Questions? That's it. Woo. No questions? Safe enough? You feel safer already?
Yeah.
That's right. Smile, Carl.